Tuition Mobile, quality e-learning experience on the go.
We are supposed to learn at the end of this lecture the differences between unsaturated solution, a saturated solution, and a supersaturated solution. Also, you should be able to read and interpret the solubility curve, and as well identify solvents that fats, oils, and paints can dissolve in, and also how these solvents can actually be useful to us in removal of stains. Also, to describe a suspension and a collage. Let's look at some technical terminologies. A solution is an homogeneous mixture which contains particles of a typical ion or a covalent molecule. Collage is a homogeneous mixture which contains particles of diameters ranging between 2 to 500 nanometers. Suspensions are mixtures which have even larger particles ranging from anything above 0.6 10 raised to the power minus 6. 10 raised to the power minus 6. Anything above that size is suspension. Now, a solute is a substance that is dissolved in a solution, and a solvent is that substance that dissolves the solute. Solvent is usually the major part of the solution. A solution is said to be saturated when an additional solute cannot be dissolved in it at a particular temperature, which means the ability of a solvent to withhold a solute is dependent on temperature. A supersaturated solution can be formed when more than the equilibrium amount of solute is dissolved in an elevated temperature. At an elevated temperature, yeah. Supersaturated, you increase the temperature, you add the solute, you increase the temperature and add solute, and then you can leave it, let it cool off. When it cools off, it comes out as a supersaturated solution because it is ready to give off the excess of what has been added to it readily. Also, we have the unsaturated solution. Unsaturated solutions are solutions that can actually accommodate more of the solute at a particular temperature. Now, we have different kinds of solutions. We have gas and gas solutions, we have gas and liquid solutions, we have gas and solid solutions, liquid and liquid solutions, liquid and solid solutions, solid in liquid solutions, and solid in solid solutions. Examples are given in the slides, as you can see. And also, differentiating between solutions, colloids, and suspensions. We have there. Solutions don't settle, colloids don't settle, but suspensions do settle. Solutions pass through ordinary filter papers unchanged. Colloids do the same, but suspensions, of course, they change. Solutions pass unchangeably through membranes. Colloids actually can be separated by membranes, and same as suspension. Solutions do not scatter light. Colloids do scatter light, same as suspension. They do scatter light as well. And solubility. The amount of a solute per unit solvent required from a saturated solution is called solute solubility. We have a formula that describes that. We'll see the formula shortly. Now, this is our solubility curve. Solubility curve simply indicates, it shows the solubility and the temperature range of the particular compound or substance. For example, let's take in this example, let's take copper trisulfate 6. Copper trisulfate 6 at room temperature, let's say 25 degrees Celsius, can only be accommodated in water up to about this is about 22 grams in 100 mils of water, 100 milliliter of water. And as well, we look at glucose. Glucose will dissolve readily in water, even up to 91 will dissolve readily in water, even at 20 degrees Celsius. Now, this shows that of solubility of gases. If you observe, solubility of gases is in opposite direction. Yeah, that's because gases are different from solids, and that's how their solubility curves do come out. Yes, gases are actually affected slightly by pressure. Their solubility is slightly affected by pressure. And there we have the solubility equation. Solubility equals to the mass divided by the molar mass of the substance multiplied by 1000 divided by the volume of the solute. Importance of solvents. Solvents like kerosene, petrol, ammonia solution help us to remove fat, oils and grease from our clothes. Turpentine help us to remove paint stains. Perfumes and oils are dissolved by use of alcohols, and iodine used in medicine is also dissolved by means of ethanol. Vulcanizers use benzene to melt and dissolve rubber alongside some other components, and so solvents are very important in our work. Colloids. Now, there are three types of colloids. We have the sols and gels. These are solid in liquid colloids. They are solid in liquid colloids, as what they are called sols, and most of them tend to solidify and form something jelly-like. Examples of them of the such components are starch and glue. Aerosols are liquids in gas colloids. The fog and smoke are kind of like most common examples we have. We also have examples like the regular spray, our air fresheners and the likes. The emulsions are liquid in liquid colloids. Now take note, the coagulation of colloids. Fine, the particles inside the colloid cannot be separated by physical means directly by normal filtration, but it can be separated by introducing some ions, some metallic ions into the solution. Suspension. Unlike colloids, suspensions have their particles are bigger and they can be seen with the natural eyes. So they do not, and no matter how small they may seem to be, they do not dissolve in water. As a matter of fact, when it gets to a certain level, we get confused. We may not be able to distinguish between a suspension and a colloid when the particles are too small. And of course, harmattan is an example of a suspension. It's a wind blowing across dust from all the way northeastern wind, blowing dust from over the Sahara Desert and coming towards us.
Fusion Mobile, quality e-learning experience on the go.